June 1942. The siege of Sevastopol is grinding into its 8th month. The city is being torn apart by the most concentrated artillery bombardment in human history. But the men in Fort Maxim Gorky, a massive concrete and steel fortress dug into the rock, have learned to live with the shelling. They've learned to distinguish the whistle of an incoming 155 howitzer from the shriek of a 210 mortar, to know when to brace and when to ignore. They trust the rock. The rock has held for months. The rock will hold. On the morning of June 6th, the bombardment begins again. But this time, there is something different. A sound no one has ever heard before. Not a whistle, not a shriek. A tearing, as if the sky itself is being ripped apart. A shell the size of a fuel truck, weighing over 7 tons, is coming down at them at nearly twice the speed of sound. It has been in the air for 45 seconds. It has climbed to the edge of the stratosphere before beginning its descent, and it does not explode on contact. It punches. It drills. It goes through 10 feet of reinforced concrete, then another 30, 40, 50 feet of solid limestone. And only then, deep in the rock that was supposed to protect them, does the fuse finally trigger. The explosion does not wreck the fortress. It vaporizes a section of it from the inside out. The shockwave doesn't just kill men, it liquefies their internal organs before their brains can register the light. The men in the neighboring bunkers, the ones who survive, do not understand what just happened. They are combat engineers. They know artillery. This was not artillery. This was an earthquake with a postal code. A few kilometers away, a second shell comes down. This one is aimed at an underground ammunition depot the Soviets thought was invulnerable. They had put it 30 meters below the surface, beneath a bay, believing that no weapon on Earth could reach it. The shell enters the water, punches through the seabed, tunnels through mud and rock, and detonates directly inside the magazine. The resulting chain explosion is so violent that it alters the coastline. A bay becomes a crater becomes a grave. Now imagine being a Soviet commander receiving the report. Your strongest fortification, the one you were told was impregnable, has been gutted by a single shot. Your hidden arsenal, the one you were sure no German plane could ever reach, has been erased from the map by something that came from below. You do not know what fired these shells. You do not know where it is positioned. You just know that somewhere beyond the horizon there is a gun that can kill a mountain, and it is looking at you. That gun was real. It was not a fleet of bombers. It was not a missile. It was a single artillery piece, a cannon so large that it required its own railway, its own battalion, its own anti-aircraft regiment just to exist on a battlefield. A cannon that fired shells weighing more than a fully loaded pickup truck. A cannon whose barrel was longer than a tennis court. A cannon whose name would become a dark legend whispered by engineers and historians alike. Schwerer Gustav, Heavy Gustav, the largest gun ever built. And that is not hyperbole. That is not a metaphor. We are going to talk about what this thing was, what it actually did, and most importantly, what it tells us about the terrifying, idiotic, magnificent dead ends that military engineering can drive straight into when nobody has the nerve to say no. And now you're asking the obvious question, the one that should be hanging in the air after hearing about a gun that can kill a mountain. Why? What kind of mind looks at the business of warfare and thinks, you know what we need? A cannon so big it has to be delivered by train. A cannon that takes 2 days to set up, an entire regiment to operate, and fires a shell heavier than a pickup truck. That's the missing piece. On the surface, it looks like insanity. The kind of cartoonish over-engineering that only a regime drunk on its own propaganda could produce. And there's some truth to that. But if we leave it there, we miss the genuinely interesting part. Because Schwerer Gustav was not born from madness. It was born from a very specific, very logical, and at the time, very reasonable set of problems. The fact that it became a monument to waste and dysfunction is not a story of stupidity. It's a story of what happens when a perfectly good answer walks straight into a question that's already been replaced. To understand Gustav, you have to rewind past the war, past the Nazis, all the way back to 1918. The First World War had just ended, and the Germans had spent the last year of it firing a weapon that would haunt the nightmares of military planners for the next 2 decades. The Paris gun. You've probably heard of it. It was a railway gun with a barrel so absurdly long that it could hurl a shell over 130 kilometers into the city of Paris from behind German lines. It was not accurate. It was not particularly destructive, but it was terrifying in a completely new way. Here was a weapon that did not need to win a battle. It just needed to announce, calmly and repeatedly, that nowhere was safe. Not your capital, not your deepest bunker, not the place where your children sleep. That idea burrowed deep into the collective military psyche. The Paris gun was a failure as a practical weapon, but it was an unparalleled success as a psychological one. And after the war, when engineers around the world sat down to imagine the next war, because they always do, they kept coming back to the same image. A gun that could reach out across borders and smash the enemy's strongest fortifications before they even knew the battle had started. Now fast forward to 1934. The Nazis are in power. The Treaty of Versailles, which had banned Germany from possessing heavy artillery, is being ignored more openly by the day, and sitting squarely between Germany and any ambitions it might have in Western Europe is a single, maddening obstacle: the French Maginot Line. People today love to mock the Maginot Line. They treat it like a punchline. But in 1934, it was not a punchline. It was the most advanced defensive fortification on the planet. Hundreds of kilometers of interconnected fortresses, buried deep under reinforced concrete and earth, designed to withstand any bombardment then imaginable. To the German General Staff, the Maginot Line was not a joke. It was a locked door, and they needed a key. Now, here's where the timeline gets really important, and where a lot of cheap hindsight falls apart. In 1934, the idea that you could just fly over the Maginot Line and bomb it into submission was not obvious. It was not even plausible. Heavy bomber aircraft at the time were slow, underpowered, and about as precise as throwing a brick out of a moving car. The dive bomber, the Stuka, the thing we all picture when we imagine close air support, that was still on the drawing board. The Luftwaffe was barely a secret sketch. If you were a German war planner sitting in a room in 1934, staring at a map of France, and your job was to guarantee that you could destroy a fortress buried under 30 meters of rock and concrete, you did not have an air force that could do it. You had artillery. That was it. That was the tool. So the question became, can we build a gun that can punch through the Maginot Line? Not harass it, not suppress it, kill it. A gun that can put a shell through 7 meters of reinforced concrete from a distance so far away that the enemy's artillery can't reach back. That was the requirement. 7 meters of concrete. Not the 3 meters of a standard bunker, not the 5 meters of a heavy fortification. 7. Because the French kept building thicker walls. This is the moment where the logic locks into place. If you accept the premise that heavy bombers are not yet reliable, that dive bombers don't exist, that ground attack aircraft are a fantasy, then the idea of a super heavy siege gun is not crazy. It is the only option. Nobody was sitting in Berlin, twirling a moustache and thinking about building a giant cannon just for the spectacle. They were solving a specific military problem with the only tool available at the time. It just so happened that the tool they needed was, by the normal scale of things, completely insane. Krupp, the German steel and armaments giant, was given the contract. And Krupp, being Krupp, did not ask whether it was a good idea. They asked how big it needed to be. The answer came back from the artillery board: 800 millimeters. That is not a typo. An 800 millimeter caliber. For comparison, the main guns on most battleships were around 400 millimeters. This was double. This was not a gun. This was a building that fired projectiles. Krupp estimated the barrel alone would weigh over 100 tons. The full assembly would be the size of a factory. The shells would be so large they'd need their own custom rail cars just to move them from the factory to the firing position. And the cost? Astronomical. The kind of money that could build an entire squadron of bombers, or a fleet of tanks, or feed an army for a season. And yet, it was approved. Not just by the generals, not just by Hitler, who was personally fascinated by the project and treated it almost like a patron of the arts commissioning a masterpiece, but by an entire military procurement system that was, at that moment in history, completely aligned with the idea that bigger meant better. This is the part of the story that should make us uncomfortable. Not because it's about Nazis, but because it's about us. About how organizations, even very smart ones, can lock themselves into a line of thinking that makes perfect sense within its own little bubble, and then fail to notice when the bubble pops. Because while Krupp's engineers were machining the first barrel sections, the rest of the world was moving on. By the time Gustav was actually finished, the Maginot Line had already been bypassed, not by a supergun, but by tanks driving through a forest in the Ardennes. The strategic problem the gun was built to solve had vanished before the gun ever fired a shot in anger. Gustav did find a target eventually. We know that from the first part of this story. Sevastopol, a fortress city, a desperate siege. A problem that, on paper, looked a lot like the one Gustav was originally designed for. And the generals, now stuck with the most expensive artillery piece ever built, decided to use it. Not because it was the best tool, but because it was there. Because it had to be used. Because the sheer weight of the investment demanded it. And that, right there, is the real lesson. Gustav was not an evil plot. It was not a madman's fantasy. It was what happens when you put a brilliant engineering culture inside a system that cannot say no. Give it a problem that is already being solved by other means, and then refuse to cancel the project because too much money, too much ego, and too much steel have already been poured into it. What comes out the other side is not a weapon. It's a fossil. A perfect, terrifying, beautifully engineered fossil of a question nobody was asking anymore. So now we know why it was built. We know the logic, the context, the trap. Next, we need to look at what this thing actually was. Not the legend, not the myth. The machine. What it took to move it, to assemble it, to aim it, and finally, to fire it. Because the engineering details of Gustav are, if anything, even more absurd than the strategic ones. So now we know the logic, we know the trap, and we know that somewhere in the bowels of the Krupp works, a monster is taking shape. Let's talk about the machine itself. Not the legend, not the propaganda photos, but the actual physical object. Because to understand why Gustav was a dead end, you first have to appreciate the sheer, staggering scale of the thing. And I don't just mean big. I mean category-defying. I mean a machine that doesn't fit into any normal frame of reference unless you start comparing it to buildings. Okay, so where do you even start with something like this? Let's start with the number everyone throws around. 800 millimeters. The caliber. That's the diameter of the shell, and by extension, the diameter of the barrel it flies out of. 800 millimeters. To give you a sense of how absurd that is, the main gun on a battleship like the Bismarck, which was considered a massive naval rifle, was 380 millimeters. The biggest Allied battleships carried 406 millimeter guns. So Gustav's barrel wasn't just bigger, it was double. You could look at the bore of this thing and see a circle of darkness wide enough for a grown man to crawl into. In fact, that's not a metaphor. The barrel was 80 centimeters across. A small adult could absolutely fit inside it. The shells, the actual projectiles, came in two flavors. There was the high explosive shell, which weighed 4.8 tons. That's already heavier than most cars on the road today. And then there was the armor-piercing shell, the one designed to kill fortresses. 7.1 tons. That is, and I'm not kidding, the weight of a fully loaded Ford F-150 pickup truck. Fired out of a cannon. Think about the forces involved in that. Think about what has to happen inside a steel tube to accelerate a pickup truck to over 700 meters per second. The chamber pressure, the heat, the stress on every single component. This is not just an artillery piece. This is a controlled explosion designed to survive another, much larger explosion, thousands of times in a row. Well, not thousands. We'll get to that. The barrel itself was over 32 meters long. That's longer than a tennis court, longer than a basketball court. It was built in two sections, a front and a rear, which had to be screwed together on site like some kind of satanic plumbing project. The entire gun assembly, just the barrel and its breech, weighed over 400 tons. And because a barrel that long and that heavy droops under its own weight, yeah, gravity is a thing even for Nazi superweapons. It couldn't just sit on a normal mount. It had to be supported by an enormous cradle, a structure of steel girders and hydraulic cylinders that looks less like a gun carriage and more like the launch tower for a small rocket. The whole business, the barrel, the cradle, the recoil mechanism, sat on a platform that spanned two parallel railway tracks. A single set of rails would have crumpled like tin foil under the first shot. So Gustav travelled on its own custom-built double-track railway. And here's where we start to see that this thing was less a piece of artillery and more an infrastructure project that occasionally made loud noises. Gustav couldn't just pull up to a hill and start blasting. It required a dedicated section of track to be laid, perfectly straight and perfectly level at the firing site. The track had to curve so the gun could be aimed left or right, because the gun itself had no traverse. Zero. The entire aiming system for lateral movement was the railway track. You moved the whole 400-plus ton assembly by shifting it along the curved rails. Precision engineering, 19th century style. The crew required to operate this thing was not a gun crew. It was a small town. Around 250 men for the gun itself, plus a full anti-aircraft battalion, plus engineers, plus railway workers, plus cooks and medics. Something like 4,000 people were involved in keeping Gustav operational. A major general was put in command. A general for a single gun. The assembly process, once the train arrived at the prepared site, took 54 hours. That's 2 full days of heavy lifting, with custom-built gantry cranes that had to be erected over the tracks just to piece the monster together. The shells and propellant charges arrived on separate trains. Each shot required a main charge and a supplementary charge, packed in silk bags, because of course they were silk. A single shot consumed about 2 tons of propellant. The barrel life was estimated at maybe 300 rounds before it had to be sent back to the factory to be relined. 300 shots. That's it. After that, the most expensive gun in history was a paperweight. And the rate of fire? About 1 round every 30 to 45 minutes, if everything went perfectly, which it almost never did. And the sound? There are no recordings, obviously. But witnesses described it not as a bang, not as a roar, but as a physical presence, a pressure wave that knocked the air out of your lungs if you were standing too close. The gun crew wore special cotton suits and ear protection, and they still came away from every shot with headaches that we're going to explore next. Because now we have to talk about what it actually took to move this thing from Krupp's factory in Essen to a battlefield in Crimea. The logistical nightmare that was, in many ways, an even bigger engineering challenge than the gun itself. And that gap, the one between making it work and making it useful, is where we're going now. Because if you thought the engineering of the gun itself was insane, the logistics of getting it anywhere near a battlefield were, honestly, even worse. And this is the part of the story that usually gets skipped in the documentaries. They show you the big gun, they show you the explosion, and they don't tell you that the real miracle wasn't firing the thing. The real miracle was getting it to the firing position without collapsing every bridge between Berlin and Sevastopol. Let's start with a number that should immediately recalibrate your sense of scale. The total weight of the Gustav assembly, including the gun, the cradle, the platform, and the support equipment, was 1,350 tons. That's not a typo. 1,350 for a single artillery piece. To move this thing, it had to be broken down into 5 major sections: the barrel halves, the cradle, the platform, and the breech, each one loaded onto a specially built railway car. And when I say specially built, I mean nothing like this existed before. Krupp had to design and manufacture an entire fleet of custom rail transport just for Gustav. The barrel sections alone rode on cars that had to be reinforced beyond any normal freight standard. The axles, the bearings, the couplings, everything was pushed to the absolute limit of what early 1940s metallurgy could handle. The train that carried Gustav from Germany to the front was not a train. It was a procession. 25 cars long, a rolling factory. And here's the detail that really gets me. This train could not travel on standard railway lines. Not because of the weight, though that was bad enough, but because the barrel sections were so long that they couldn't negotiate normal curves. The turning radius of a standard European railway curve was too tight. So Gustav's route had to be planned months in advance, surveyed by engineers who checked every bend, every bridge, every tunnel along the way. If a curve was too sharp, they couldn't just go around. They had to either modify the track or find an entirely different route. Sometimes that meant adding hundreds of kilometers to the journey. From the Krupp works in Essen to the Crimea, the distance as the crow flies is about 2,000 kilometers. The actual route Gustav took was far longer, winding through Germany, Poland, Ukraine, crawling south at a speed that would have been overtaken by a determined cyclist. And then you arrive. Congratulations. You've gotten the largest gun in history to within a few dozen kilometers of the front. Now what? Well, now you have to find a place to put it. And not just any place. You need a stretch of ground that is perfectly flat, perfectly straight, with solid enough soil to support the weight of the gun and its double-track assembly, and you need it to be within range of your target, which for Sevastopol meant about 25 to 30 kilometers from the city. Anything closer, and the Soviet coastal batteries, which were themselves massive guns, would be able to reach you. Anything further, and you can't hit the fortresses you came to destroy. So you've got a very narrow band of real estate to work with. And you can't just pull up and start shooting. Oh no. First, you need a railway spur to be built from the main line to your chosen firing site. This is not a siding for a freight wagon. This is a specially engineered, perfectly leveled double-track curve that will allow the gun to be aimed by sliding along the rails. The preparation of the firing position took weeks. Hundreds of workers, many of them forced laborers, digging embankments, laying track, compacting soil, building platforms for the gantry cranes. The cranes themselves, by the way, had to be brought in on their own train and assembled on site before they could even begin assembling the gun. And all of this, every single rail, every crane, every worker, every supply train bringing food and water and ammunition, all of it had to be protected, because a target this large, this expensive, this utterly immobile, is an air commander's dream. The Soviets knew something big was being built. Their reconnaissance planes spotted the activity. So Gustav required its own dedicated anti-aircraft regiment. We're talking dozens of heavy flak guns, searchlights, radar if it was available, plus a constant combat air patrol from the Luftwaffe. Thousands of men whose only job was to sit around a single gun and make sure it didn't get bombed before it could fire its handful of shots. And then there's the ammunition. Remember those 7-ton shells? They didn't just come in a box. Each shell required its own specialized carrier. The propellant charges, those silk bags I mentioned, were separate, stored in climate-controlled cars because the propellant was sensitive to temperature and humidity. A single firing sequence involved a choreography of loading that makes a ballet look improvised. The shell had to be hoisted by a small crane built into the gun platform, carefully aligned with the breech and rammed in with a mechanical rammer. Then the main propellant charge, then the supplementary charge. The breech had to be sealed, the elevation set, the calculations checked and rechecked. The barrel, remember, was not built to last. After just 15 shots, the barrel's performance was already measurably different from the first round. After 100, it was a different gun. And through all of this, the gun was fixed in place. It could not move. It could not reposition. If a Soviet counter-battery got lucky, or if the front shifted unexpectedly, Gustav was a sitting duck. The most powerful artillery piece in history was also one of the most vulnerable targets on the logistical black hole that consumed resources on a scale that would have made a battleship blush. And here's the kicker. All of this effort, all this steel, all this sweat, what did it actually achieve? That's where we're going next, because the gap between the legend of Gustav and the reality of what it did in combat is, if anything, even wider than the gap between the gun and the nearest usable railway line. So after all that, the years of development, the millions of Reichsmarks, the custom railway, the thousands of men, the weeks of preparation, Gustav finally fired its first shots in anger. And almost immediately, the stories started. The legends, the myths. Some of them were born in the heat of battle, exaggerated by soldiers who had just witnessed something impossible. Some of them were carefully cultivated by Krupp's PR machine, which had a vested interest in making their monster look like a war winner. And some of them just sort of appeared, the way myths do, passed from one book to another, one documentary to the next, until they became accepted as fact. So before we talk about what Gustav actually did, we need to clear away what it didn't do. Because the gap between the legend and the reality is where the real story lives. Let's start with the big one. The one you've probably heard if you've heard anything about Gustav. One shot, one fortress. The idea that this gun could point its barrel at a massive concrete fortification, fire a single shell, and reduce it to rubble. It's a hell of an image. It's also, for the most part, not true. Now, I'm not saying Gustav couldn't destroy a fortification. It absolutely could, and it did. We already talked about Fort Maxim Gorky and the ammunition depot at Severnaya Bay. Those were real hits with devastating consequences. But the idea that every shot was a guaranteed fortress killer, that the gun was some kind of point-and-click delete button for enemy strongholds, that's fantasy. Here's why. First, accuracy. When you're firing a shell from 25 or 30 kilometers away, even with the most sophisticated fire control of the 1940s, you're not hitting a pinpoint target. You're aiming at a general area and hoping the shell lands close enough to do damage. The circular error probable, that's the radius within which half your shells will land, for a gun like Gustav was not 0. It was tens of meters, sometimes more. Against a city-sized target, that's fine. Against a specific bunker buried in a hillside, it means you might need multiple shots to get a direct hit. And every shot degraded the barrel, cost a fortune, and took 40 minutes to reload. This was not a sniper rifle. This was a sledgehammer being swung at a nail from across a football field. Sometimes you hit the nail. Sometimes you just make a very expensive hole in the dirt. Second, penetration physics. The armor-piercing shell was designed to punch through concrete and then detonate, but it didn't work like a laser. The angle of impact mattered enormously. A shell hitting at a shallow angle could ricochet off, even against concrete. The type of rock and soil between the surface and the target mattered. The quality of the concrete mattered. German tests before the war had shown that the shell could penetrate up to 7 meters of reinforced concrete under ideal conditions. But battlefield conditions are never ideal. Some of the Soviet fortifications at Sevastopol had been reinforced with extra layers of concrete and steel, or were built into rock formations that deflected the shells in unexpected ways. Gustav's shells were powerful, but they were not magical. And then there's the most uncomfortable fact for the mythmakers. Gustav missed. Not often, but it missed. Some shells landed in the sea, some landed in empty fields, some hit their targets but failed to detonate properly because the fuse was damaged by the impact. War is messy, even for a 7-ton shell. So if the one-shot, one-fortress myth is an exaggeration, what about the other big claim? The one you see repeated in books and documentaries. Gustav won the siege of Sevastopol. This one makes me want to throw things. Look, Sevastopol was a massive operation. The German assault involved hundreds of thousands of men, thousands of artillery pieces, and weeks of concentrated bombardment. The city was being pounded by everything from mortars to heavy howitzers to dive bombers. Gustav fired 48 shells during the siege. 48. Over the course of several days. That's not a battle-winning contribution. That's a footnote. A very loud, very expensive footnote. The siege was won by the cumulative weight of conventional artillery and infantry assault, not by a single supergun. Soviet accounts of the battle barely mention Gustav. To them, it was just one more shell among hundreds of thousands. The fact that it was bigger didn't make it strategically decisive. So where did these myths come from? Partly from the Germans themselves. Krupp produced a propaganda film about Gustav after the battle, showcasing the gun's size and power. The Nazi press played up the wonder weapon angle, desperate for good news as the war started to turn against them. And after the war, a lot of the documentation was lost or destroyed, leaving a vacuum that was filled by memoirs. And memoirs are tricky things. They're written by people with egos and agendas. The officers who commanded Gustav wanted to believe their weapon had made a difference. The engineers who built it wanted to justify the resources they'd consumed, and the historians who came later, working with incomplete records, sometimes took these self-serving accounts at face value. But here's the thing. Even if we strip away the myths, even if we look only at the cold, hard, verified facts, Gustav's combat record is still something. It's just not the something you've been told. And that's what we're going to look at next. The real story of those 48 shells, what they hit, what they missed, and what it all meant. Because the truth is, in some ways, even stranger than the legend. Alright, so we've cleared away the myths. We know that Gustav was not a magical fortress deleter, and we know it didn't single-handedly win the siege of Sevastopol. So what did it actually do? What were those 48 shells fired at, and what happened when they landed? Let's walk through the verified combat record. Not the propaganda, not the memoirs, but the cold, hard, cross-referenced facts. Because the truth, as usual, is more interesting than the legend. Gustav arrived in Crimea in early June 1942, and its operational window was tiny. The gun fired its first shot on June 5th and its last on June 17th. That's less than 2 weeks of combat, spread across several firing days. The rest of the time was spent moving, assembling, waiting for targets, or repairing the inevitable mechanical issues that come with operating a one-of-a-kind prototype under battlefield conditions. 48 shells total. That's the number most historians agree on. Not 500, not 100, 48. And each one of those shots was meticulously logged, because when you're spending the equivalent of a small aircraft on every pull of the trigger, you keep receipts. The first major target was Fort Maxim Gorky I, the massive coastal battery we talked about in the opening. This was a priority target for the entire German artillery effort, not just Gustav. The fort had been pounded for days by everything from heavy mortars to dive bombers. But its main turrets, protected by layers of concrete and steel, were still operational and still firing back at the German lines. Gustav was brought in to finish the job. Over several days, the gun fired multiple shells at the fort. And here's where the record gets nuanced. Some of those shells hit the main battery directly. The damage was severe. Concrete shattered, gun turrets jammed, underground galleries collapsed. But the fort was not destroyed by Gustav alone. It was a cumulative effort. Gustav's shells were the knockout punches, but only after days of preparatory bombardment had weakened the structure. By the time the German infantry finally stormed the position, the defenders were already dazed and bleeding. Gustav had done its job, but it had not done it in isolation. Then there was the ammunition depot at Severnaya Bay, which we already touched on. This was Gustav's most spectacular success. The depot was buried 30 meters underground, beneath the waters of the bay, in a location the Soviets believed was completely immune to direct attack. Gustav fired a single armor-piercing shell. The shell entered the water, punched through the seabed, and detonated inside the magazine. The resulting explosion was so massive that it was felt kilometers away. For weeks afterward, German troops reported finding chunks of concrete and twisted metal scattered across the surrounding hills. This was, by any measure, an extraordinary feat of marksmanship and engineering. One shot, one destroyed target. But notice the pattern. The target was stationary, Its location was precisely known, and the hit was facilitated by days of reconnaissance and surveying. This was not a dynamic combat situation. This was an industrial demolition project conducted through the medium of artillery. Other targets were less dramatic. Gustav fired at fortifications along the Soviet defensive line, at command posts, at supply dumps. Some shots hit their targets and caused significant damage. Some missed entirely, the shells burying themselves in the soft Crimean soil without detonating. A few were duds, 7 tons of high explosive that just plowed into the ground and sat there, useless and terrifyingly unpredictable. German engineers had to be sent forward after the battle to disarm these unexploded shells, which must have been one of the least desirable jobs in the entire Wehrmacht. Imagine walking up to an unexploded Gustav shell and thinking, yeah, I'm qualified for this. And here's the thing that rarely gets mentioned. After the siege, German officers conducted a detailed after-action review of Gustav's performance. The report was classified, but fragments have survived, and they are, to put it mildly, ambivalent. The gun was praised for its destructive power, but the report also noted that many of its targets could have been destroyed just as effectively by conventional heavy artillery or dive bombers, at a fraction of the cost and logistical burden. The report questioned whether the results justified the resources expended. Even the Nazis, in the middle of a war, were asking themselves, was this thing worth it? The answer, in cold, strategic terms, was no. Gustav's combat career was not a triumphant march. It was a brief, expensive, and ultimately inconclusive cameo in a siege that would have been won without it. The gun was packed up, shipped back to Germany, and spent most of the rest of the war sitting in storage, waiting for a mission that never came. There were plans to use it at Leningrad. There were plans to use it against the Allies in Normandy. None of them materialized. Gustav fired its last shot in 1942. After that, it was just a very large, very expensive piece of scrap metal, consuming maintenance hours and occupying railway sidings while the Reich collapsed around it. So the combat record is a microcosm of the entire Gustav project. It worked. The engineering was sound, but the gap between working and being useful was never bridged. And that gap is what defines Gustav's legacy, far more than any crater it left in the ground. So at this point, you might be thinking, okay, Gustav was a boondoggle, a one-off, the kind of mistake that happens when a regime gets high on its own propaganda and nobody has the guts to cancel a project.
And that's a comforting thought, because it means the system worked most of the time. And Gustav was just a weird exception, a freak, a single spectacular wrong turn in the history of military engineering. The problem is, that thought is wrong. Gustav was not unique. It was not even the only gun of its kind. It was part of a pattern that stretched from the 1930s all the way to the final days of the war. A pattern of building things that were too big, too heavy, too expensive, and too logistically demanding to ever be strategically useful. Gustav was the biggest, sure, the poster child, but it had siblings. Let's start with the most direct comparison, Dora. You've probably seen that name attached to Gustav in old books or documentaries. Some sources even use them interchangeably as if they were the same gun. They weren't. Dora was the second gun of the Gustav class. That's right. The Germans built 2 of these things. 2. The second one was named after the wife of the chief engineer at Krupp, because nothing says romance like naming an 800mm siege cannon after your spouse. Dora was virtually identical to Gustav in every respect. Same caliber, same size, same logistical nightmare. And its combat career? Even shorter. Dora was deployed briefly to the Eastern Front, but never fired a shot in anger. The advance of the Red Army forced it to retreat before it could even be set up. All that steel, all that effort, all those Reichsmarks, and Dora spent the war being shuttled from one storage siding to another, a monument to sunk cost fallacy, dressed up as a strategic asset. And then there was Karl. Mercer Karl. That's Mortar Karl, if you want the translation. Karl was smaller than Gustav, but smaller is a relative term when you're talking about Nazi superweapons. Karl was a 600mm self-propelled mortar. Self-propelled, in this context, means it could crawl along on its own chassis at a blistering top speed of 10 kilometers per hour. It was designed to fire massive concrete-piercing shells at close range. 7 of these were built. 7. And they actually saw combat at Sevastopol alongside Gustav, and later in the Warsaw Uprising. Karl was, by all accounts, moderately effective in its very narrow role. But it suffered from the same fundamental problem as Gustav. The juice was never worth the squeeze. The resources poured into building and maintaining a fleet of super-heavy mortars could have produced dozens, maybe hundreds, of conventional artillery pieces that would have been more flexible, more survivable, and more useful across the entire front. And if you think Gustav and Karl were the limit of German ambition, let me introduce you to the Landkreuzer P1500. The Landkreuzer P1500. This was not a gun. This was a fever dream rendered in steel. The idea was to take Gustav's 800mm cannon and mount it on a tracked, self-propelled chassis. A tank. A tank the size of a building. The P1500 would have weighed over 1,500 tons, powered by 4 U-boat engines, with armor thick enough to shrug off anything short of a direct hit from a battleship. It would have been the largest land vehicle ever conceived, and it never got past the design stage because someone, mercifully, realized that building a mobile Gustav was like trying to make a bulletproof elephant. Even if you succeed, you've still created something that can't move, can't hide, and consumes everything in its path. Now, here's why this pattern matters. It's easy to look at these projects and laugh, to file them under Nazi incompetence or Hitler's megalomania and move on. But that's too simple. The engineers who designed these weapons were not stupid. The generals who approved them were not all delusional fanatics. They were caught in a system that rewarded scale over efficiency, spectacle over strategy. A system where saying no to a project backed by the Führer was a career-ending move, and saying yes came with unlimited funding and a chance to build something the world had never seen. The superweapons program was not a bug in the Nazi war machine. It was a feature, an emergent property of a procurement culture that had lost the ability to distinguish between impressive and useful. And that brings us to the real question. Not was Gustav unique, but was Gustav doomed from the start? Was there any scenario, any battlefield, any war where a gun like this could have justified its existence? Or was the whole concept a dead end, a beautiful and terrifying dead end, from the moment the first blueprint was unrolled? That's where we're going next. Because the answer to that question isn't just about a gun. It's about how civilizations make decisions, and what happens when nobody has the nerve to say enough. So let's pull the camera back. We've looked at the myths, the reality, the logistics, the siblings. And now we need to answer the big, uncomfortable question that's been hovering over this entire story. Was Gustav just a victim of circumstance? A brilliant weapon that happened to be born on the wrong side of history? If Germany had been winning the war, if the Luftwaffe had total air supremacy, if the front lines had stayed stable for months on end, would Gustav have been worth it? And the answer, I think, is no. Not probably not. Not it depends. Just no. Gustav was a dead end, not because the Nazis lost, but because the concept itself was fundamentally broken. And I want to walk through why, because the reasons matter. They matter beyond this one gun, beyond this one war. They're the same reasons that projects fail today, in militaries and corporations and startups. The same pattern of smart people pouring genius into a container that was never going to hold water, no matter how beautifully they sealed the seams. There are 3 reasons Gustav was doomed. Not 3 opinions, 3 structural flaws. And they're all connected. The first, and most damning, is simple economics. The alternative cost. Every Reichsmark spent on Gustav was a Reichsmark not spent on something else. That's not a platitude. That's the fundamental law of resource allocation. The Gustav project, from design through construction through deployment, cost an estimated 7 million Reichsmarks. In wartime currency, that's a slippery number, so let's translate it into something more concrete. For the cost of Gustav, Germany could have built approximately 50 standard heavy howitzers, or 150 medium tanks, or an entire squadron of bombers with enough left over for spare parts and pilot training. 50 howitzers. Think about that. 50 guns spread across the front, each one mobile, each one replaceable, each one capable of firing dozens of shells a day instead of one every 40 minutes. Gustav delivered 48 shots in its entire combat career. A battery of conventional howitzers could deliver that many shells in under an hour, and those howitzers could move. They could relocate after firing, avoid counter-battery, and support infantry in real time. Gustav, as we've established, was a sitting duck that took 2 days to set up and 2 days to take down. The economic argument alone is a kill shot. Any weapon that costs the same as a small fleet of alternatives while delivering a tiny fraction of their total combat output is, by definition, a bad investment. And that's before we factor in the maintenance costs, the dedicated crew, the anti-aircraft battalion, the railway engineers. Gustav didn't just cost money to build, it cost money to own. Every day it sat in storage, it was burning resources that could have gone to something useful. The second flaw is technological obsolescence. And this one is especially cruel because it wasn't anyone's fault. It was just time. Gustav was designed in the mid-1930s to solve a problem that by the time the gun was operational had been solved by other means. That problem was the impregnable fortress, the deep bunker buried under concrete and rock that no conventional weapon could touch. In 1935, the only way to reach that bunker was with a very, very big shell fired from a very, very big gun. But by 1942, that wasn't true anymore. Aviation had caught up. Bomber aircraft that were experimental and unreliable in 1935 were, by 1942, carrying payloads of several tons with enough accuracy to hit bunker-sized targets. The British had developed the Tall Boy earthquake bomb, designed to penetrate deep into the ground and destroy structures from below. The Germans themselves had the Fritz X guided bomb, which could be steered onto a target with unprecedented precision. None of these solutions required a railway, a double-track curve, a battalion of support personnel, and 2 weeks of setup time. They could be delivered by a single aircraft, striking from a mobile airfield hundreds of kilometers away, and the aircraft
could be used again the next day against a different target. Gustav was a landline telephone in a world that had just invented the radio. It still worked. It still made calls. But the game had moved on. And the third flaw, the one that ties it all together, is the operational tempo. This is the killer. Even if you could somehow justify the cost, even if you could ignore the fact that aircraft were now doing the same job better and cheaper, Gustav still failed at the most basic requirement of any weapon. It couldn't keep up.
A weapon that takes 2 days to set up and can only fire once every 40 minutes is not a tool for fighting a war. It's a tool for fighting a siege. A very specific kind of siege against a very specific kind of target in a very specific kind of terrain with total air superiority and a static front line that doesn't move for months. That's not a weapon system. That's a planetary alignment. And the thing about planetary alignments is that they don't happen very often. Outside of Sevastopol, where exactly was Gustav supposed to go? The Eastern Front was a war of movement, of encirclements and breakthroughs and frantic retreats. The Western Front, after D-Day, was even faster. Gustav was built for a war that stopped existing somewhere around 1941. The generals knew this. The after-action reports we talked about in the last part make it clear that even the officers who operated the gun understood its limitations. But by then, the sunk cost was so enormous that admitting the truth would have been a political and personal catastrophe for everyone involved. So they kept the gun. They maintained it. They planned missions for it that never materialized. They pretended it was an asset, when in reality it was just a very heavy anchor tied to the neck of the German logistics system. 3 flaws: economic, technological, operational. Any one of them would have been enough to doom Gustav. Together, they didn't just doom it, they made it a case study. A textbook example of what happens when an organization prioritizes spectacle over substance, scale over flexibility, and the ego of a few powerful men over the quiet math of the spreadsheet. And that brings us to the end of the story. Not the end of the analysis, but the end of the gun itself. Because after all this, after the millions of Reichsmarks and the thousands of men and the 48 shells and the endless debates, what actually happened to Gustav? Where is the largest cannon in human history right now? That's where we're going next. And the answer, I promise you, is not what you expect. So after all this, the millions of Reichsmarks, the thousands of men, the 48 shells, the endless logistical headaches, what actually happened to Gustav? Where is the largest cannon in human history right now? You might expect it to be in a museum, a trophy of war sitting in some courtyard, tourists taking selfies in front of its barrel. That is not what happened. On April 14th, 1945, with the Allies closing in from the west and the Red Army from the east, a German demolition team blew Gustav apart. They didn't want it captured. They didn't want it studied. They didn't want it to become a monument to their own insanity. So they packed it with explosives, detonated the charges, and turned the most powerful artillery piece ever built into a pile of twisted scrap. The remains were discovered by American troops a few days later. They poked around, took some photographs, wrote a brief report, and moved on. The war was ending. Nobody had time to marvel at a broken superweapon. The scrap was eventually hauled away, melted down, and recycled into who knows what. Maybe railway tracks, maybe toasters, maybe the frame of a Volkswagen Beetle. There is something almost poetic about that. The gun that was supposed to conquer the world ended up as raw material for the post-war economic miracle. A few pieces survived. Some shell casings, some technical drawings,
a handful of photographs. And that's it. The largest gun in history left no intact remains, no preserved barrel, no museum exhibit.
Just a scattered archive of documents and a handful of craters in Crimea that have long since been filled in by rain and time. Dora, the sister gun, met a similar fate. It was destroyed by its own crew to prevent capture, and its remains were scrapped. Karl, the self-propelled mortar, actually survived in one case. One of the 7 Karls was captured intact by the Americans and shipped back to the United States for testing. It now sits, or at least parts of it sit, at the Aberdeen Proving Ground in Maryland. You can go see it. It's rusting quietly in a field, overshadowed by tanks and helicopters that actually mattered to the outcome of the war. And that's the epitaph, really. Not a bang, not a dramatic last stand, just a demolition charge, a scrap heap, and a few faded photographs. The largest gun in history vanished into the same industrial machine that produced it. It left no legacy, no strategic lesson that anyone wanted to learn, no successor. Nobody builds 800mm railway guns anymore. The idea died with Gustav, and nobody bothered to revive it, which, in its own way, is the most damning verdict of all. If the concept had any merit, someone, somewhere, would have tried again. Nobody did. The world took one look at Gustav, said no thank you, and moved on to missiles and smart bombs and all the other ways we've devised to destroy things from a distance. And that brings us to the final question, the one that's been hanging over this entire series. Was Gustav a monument to human stupidity, or to something else? Were the people who built it idiots, or were they something more unsettling? Smart people making rational decisions inside a system that had gone insane. That's what we're going to close with, because the lesson of Gustav is not about a gun. It's about us.